Hello students, welcome to my channel Deep Learning Biology. Today we are going to discuss about a topic of Gibbs free energy. Now before starting the discussion about Gibbs free energy, I just want to tell you about a very simple reaction. Yes, you must be knowing that hydrogen, it is going to react with oxygen and there is going to be formation of water molecules. So try to see what actually happens in this reaction. If you are going to have 2 moles of hydrogen, okay, let's suppose you are going to have 2 moles of hydrogens, then what is going to happen? It is going to react with 1 mole of oxygen and there is going to be formation of 2 moles of water molecules. So 2 moles of water molecules will be formed, and this is a very simple reaction which you must have learned in your childhood days. Now try to see this reaction. So you know very well hydrogen, it is a gas. So in a gas, what is going to happen? There is a rapid movement of gas molecules. Same way in the oxygen, there is going to be a rapid movement of oxygen molecules. So here you see you are going to have higher entropy. So you are going to have higher entropy. But here you see there is formation of liquid water. Now try to see and try to think which one is going to have higher entropy now. Yeah, here the reactant, they are going to have higher entropy, but your product, it is going to have less entropy because the water in the liquid state in comparison to the gaseous state is going to have lesser entropy. But if you remember the second law of thermodynamics, which states that in all natural process the entropy is going to increase of the universe. Yes, when we see the universe, the entropy is increasing, but here within this reaction, this is also a natural process, but here you see the entropy is going to decrease. Now question is, who is going to determine in which direction the reaction is going to move? So there is a concept of Gibbs free energy which is going to tell whether the reaction will move in the forward direction or it is going to move in the backward direction. So today we are going to learn the concept of Gibbs free energy. So let us first define what is actually a Gibbs free energy. Gibbs free energy is a measure of amount of energy available to do useful work in a process, or you can define it as portion of system energy that can perform work when the temperature and pressure are uniform throughout in a system. Now try to see a living cell. In a living cell, what you see, you are going to have constant temperature, you are going to see constant pressure. Yes, there is going to be a negligible change in the volume. Now if you take this as a system, now this is going to have some total energy, so that is going to represent the total energy of this cell. Now only a portion of the energy can do some useful work or biological work. That is known as the Gibbs free energy. Okay, so Gibbs free energy is the amount of energy which is available in any system which can carry out some useful work. Yes, in your chemistry classes you must have learned that a symbol delta, it is going to denote a change. So if you are going to use the term delta G means there is going to be a change in free energy. So try to understand, if your delta G it is going to be positive, means the system is going to require an input of energy. So here when your delta G is positive means the system is going to absorb energy from the surrounding. And such type of reaction in which delta G is positive, those reactions are also known as endergonic reaction. Another important thing, if the reaction is going to have a value of delta G that is negative, in those reactions what is going to happen? The reaction is going to give away energy to the surrounding. So such reactions actually release free energy in the surrounding. So such type of reaction, they are also known as exergonic reaction. So hopefully it is clear to you what is an endergonic reaction and what is an exergonic reaction. Now we will try to understand the concept of free energy through a graph. Let us draw a graph like this. So here on the y-axis you are going to denote the Gibbs free energy, and on the x-axis you are denoting the time. Let's suppose a reaction is going to start, and let's suppose reactant, they are going to have some energy. Now let's suppose these reactant, they cross a barrier of energy that is known as activation energy, and there is formation of final product. So here you see this is the point where your product is being formed, and this is the amount of energy available in the product. So here you see clearly that your reactant, they are going to have more energy and your product is going to have lesser energy. So let's suppose this is the point where it is going to show the energy of the reactant, and here is the point it is going to show the energy of the product. So here you see this is going to denote the change in free energy. So here if you see the value of delta G, it is going to be negative. So such type of reaction, they are actually going to release energy in the environment. And as I have told you, such type of reaction, they are known as exergonic reaction. Now try to see the another situation. So in the another situation, at the same way, your reactant is going to have lesser energy, but it will cross the same activation energy barrier and there is formation of product. So here you see the reactant is going to have less energy and your product is going to have more energy. So here if you see, this is going to denote the delta G. So here in this case, the value of delta G, it is going to be positive. You know very well, such type of reaction, they are going to be known as endergonic reaction. Always remember, the endergonic reaction, they are going to actually absorb energy from the surrounding. So hopefully it is going to be clear to you what is Gibbs free energy, what is change in free energy, and what are the reaction known as endergonic reaction and what are exergonic reaction. Now you must have learned in your previous classes that Gibbs free energy, it can be denoted by a relation. So in actually the change in Gibbs free energy, okay, so change in Gibbs free energy can be denoted by a relation, and that relation is delta G is equal to delta H minus T delta S. Now try to see what is this. This is change in free energy. Now what is delta H? Delta H is change in enthalpy. Now try to understand. for a biological system, it is very easy to define what is enthalpy. So hopefully you must be knowing H, enthalpy, is equal to E plus P and V. Now you know that in case of a cell, the work which is going to happen, it is going to happen at a constant pressure and there is going to be a constant volume. So this is going to be 0. So H is going to be E in case of a biological system. So what is E? The total internal energy. So you can say in case of a biological system, the enthalpy is actually the total energy. So delta H minus T. T here is the absolute temperature which is being denoted in the unit that is Kelvin. So whenever you have to change the temperature in Kelvin, so it can be easily done. Just you have to add 273 and whatever the temperature, it is being given in degree Celsius. Now what is delta S? It is the change in entropy. So delta S is change in entropy. So delta H is change in enthalpy and delta G is change in Gibbs free energy. Now try to see, I have told you one relation that if delta G is going to be negative, the reaction is going to release free energy. If delta G is going to be positive, the reaction is going to absorb free energy. Always remember, if a reaction is spontaneous, means if the reaction is going to happen naturally without the input of some external force, in those reactions, the delta G, the change in Gibbs free energy, is going to be negative. Now try to see here, in what condition it is going to be negative. So when you are going to have this T delta S value more, so negative term is going to be more, then the delta G is going to be negative. So try to see here, if your value of delta G is going to come out negative, okay, so it means the reaction is exergonic. Yes, it also means the reaction is spontaneous, means it can move in the forward direction. Now we will see the different situation what can occur where you are going to have different value of delta G. Yes, come to the relation delta G is equal to delta H minus T delta S. Let's suppose the value of delta H, it can be 2. Either it can be positive or it can be negative. The same way, the value of delta S, it can be either negative or it can be positive. Same way here we are taking the value of delta S, it can be negative and it can be positive. Now try to see here, when your value of delta H is positive and your value of delta S is negative, means the entropy is decreasing. Now try to see here, when you are going to have positive value of delta H and negative value of delta S. So in total what is going to happen? So here you see negative, it is going to cancel, it will become positive. Okay, so in total the whole value of delta G is going to be positive. So such reaction which are going to have delta G value positive, they are actually non-spontaneous. They are not going to occur on its own. So they are non-spontaneous. Okay. So here I just want to tell you one of the best examples, that graphite, it cannot convert into diamond at the upper surface, at the normal temperature. So that reaction is not going to happen. So those are known as the non-spontaneous reaction. Next, come to the situation. The value of delta H is positive and the value of delta S is positive, means the entropy is also increasing. So what is going to happen? Yes, in those cases the value of delta G is going to be negative. Okay, so such reactions, they are going to be spontaneous if this value of T is much higher. Yes, your value of delta S is positive, but if your temperature is higher, this whole term is going to become more negative. Okay, so here your delta H is positive, but this term is now more negative. So here the end result is that delta G is going to have negative value. So such reactions, in actually they are going to be spontaneous at higher temperature. Okay, so this is about this relation. So you can see, so in these conditions you are going to have delta G negative. Whenever delta G value is negative, you are going to have a spontaneous reaction. Yes, the value of T is going to be more, then this value, this whole term is going to become more negative. Then if you are going to have more negative term, even though you are going to have delta H positive, your delta G will be more negative. So the reaction is going to be spontaneous at higher temperature. Here I just want to tell you one of the classical example is the melting of ice. So if you are going to melt ice and if you increase the temperature, it will melt more quickly. Okay, so this is one of the reaction which is going to happen spontaneously. It is going to happen more spontaneously at the higher temperature. So hopefully you will remember the example. Now come to the another situation. The value of delta H is negative. Yes, the change in entropy is negative, means the system's entropy is going to decrease. And hopefully if you remember in the start of the lecture, I have given you one example where the entropy is going to decrease. Yes, such type of reactions, they are going to be spontaneous. So your delta H is negative and this term, okay, it is negative, but this term is going to be positive. Okay, try to think. And this has become now positive, but it must not be so much positive that it is going to subtract the value of delta H. So such reaction, try to think when it is going to be remain less in counting, and it will happen when the temperature is going to be low. So such reactions, they can also have the value of delta G negative. Yes, they are going to be spontaneous at low temperature. Hopefully it is clear to you. The value of T must be low. Next, come to the next situation. So here one of the best example is the combustion of hydrogen and there is formation of water. So you see, there is formation of water and that reaction is still going to be proceed because the value of delta G is negative. The reaction is going to be spontaneous. But if you see by the point of entropy, the entropy is going to decrease. Now come to the next situation. When the delta H value is negative and delta S value is positive. When you are going to have the value of delta S positive, means the entropy is going to increase. So in those situations, you see, so when you are going to have this positive and this is negative, what will happen? This is negative, and you see in every situation the value of delta G is going to be negative. So such type of reactions, they are actually always spontaneous. Always spontaneous. Now try to see, many times students think that if the reaction is going to be spontaneous, means it is going to occur quickly. No, this is not the meaning. Spontaneous means it is going to decide in which direction the reaction is going to occur. But it doesn't mean it is going to occur quickly. So hopefully it is clear to you that by looking into this relation delta G is equal to delta H minus T delta S, you can see that in different situation the value of delta G can be positive or it can be negative. Try to see another situation. If you see this situation, if the value of delta H and this T delta S, if they are going to become equal, let's suppose it is 10 and it is going to become 10. 10 minus 10, it is going to be 0. Okay. So in condition when you are going to have delta G value, it is going to be 0. This can happen only in one condition, when the reaction has reached at the chemical equilibrium. So when the reaction has reached at the equilibrium, then the value of delta G is 0. So you have to remember, in any reaction, if it has attained the equilibrium state, then the value of delta G is going to be 0. Try to understand what is actually a chemically equilibrium reaction. Suppose that A is going to form B. Okay, so it is going to move in a forward direction. Same way, after the end of the reaction, B is also being converted into A. Now, if rate of forward direction and as well as rate of the reverse reaction, if it is going to same, such reactions, they are going to be known as in the state of chemical equilibrium. There is another important point you must remember, that when a reaction is in equilibrium, it doesn't mean the number of reactant is equal to number of product. So we will discuss that later, but it must be clear to you, it doesn't mean that the number of reactant is going to be number of product. Yes, every reaction is going to have different of constant, and that constant is known as K. So here you can say it can easily be calculated. K, the equilibrium constant, will be the concentration of B divided by concentration of A. So this is about the Gibbs free energy, and we have learned that delta G is going to be negative for a spontaneous reaction. Yes, delta G is going to be 0 for a reaction which is going to be at the equilibrium state, and delta G, if it is positive, the reaction is non-spontaneous. Always remember one important point, that living cell, they are not at equilibrium. Something is entering, something is coming out. They are not at the equilibrium state. Try to see if the cell is going to attain the equilibrium state, you can say it is more or less dead. So a dead cell can attain the equilibrium state, but a cell which is live, in that cell something is always being formed, something is being exported out. So a living cell, it is not at a equilibrium state. And the most important point, you must remember that yes, we have discussed that in case a reaction is going to have delta G value 0, that reaction has actually reached a state of chemical equilibrium. Yes, another important point you must remember, yes, in case delta G is negative, the reaction is spontaneous, but it doesn't mean that if a reaction is going to have much higher negative value, means it is going to proceed faster and faster. There is no relation between the negative delta G value and the rate of reaction. Always remember, the rate of reaction is independent of value of delta G. Hopefully, you must have learned in your chemistry class that energy, enthalpy, entropy, they are actually the state function. What are state function? Which are going to be dependent on the initial state and the final state. Yes, I have told you now, if the value of delta G is positive, the reaction is non-spontaneous. Now, if a reaction is non-spontaneous, try to think, even the enzymes cannot promote that reaction in a forward direction if the value of delta G is going to be positive. Now, I am going to tell you about a very simple reaction. You must be knowing the first step of glycolysis. Glucose is going to be converted into glucose 6-phosphate. I just want to tell you that the standard free energy change, we are going to discuss in next class, it is going to be 13.8 kilojoule per mole for this reaction. So you see, delta G is going to be positive. But this reaction actually occurs in the cell. Now, what I have told you till now, if a reaction is going to have delta G value positive, even the enzymes cannot promote that reaction in the forward direction. But the question is, how this reaction is going to proceed in a forward direction within the cell? If you know, please write in the comments, or if you don't know, it's okay, we are going to discuss in the next class. Thank you for watching this. Have a nice time.